Welcome back, John P. Kelleher, Los Manos College. I'm with Fire 102, and again, this is a supplement to your Canvas. I'm going over week five. So the physical state of fuels and effect on combustion. Matter is made of three forms, which we went over a couple weeks ago: solid, liquid, gas. The physical state of matter can affect its combustion. Most fuels must be in their gaseous states to take part in combustion. Solid, molecules in a solid material are packed closely together. This criterion gives the material its density and its physical state. When heat is applied, the molecules ignite, become agitated, and become to collide with each other. This causes the molecules to break apart and free up components of the material. Heat that is produced causes additional molecules to break away from the solid physical state, and it becomes a gas and combusts. When the amount of heat applied exceeds the ability of the mass to dissipate, chemical breakdown occurs. The result is a self-sustaining burning reaction that continues until it is either interrupted or runs out of fuel. Second part of matter, liquid. A liquid cannot burn unless it is in suspension, which is referred to as atomization. It's the separation of atoms and molecules into an uncontrolled state where they're in suspension rather than a liquid form. You also may see this on your terms in your definitions. When a liquid will act as a heat sink and dissipate the introduced heat into the cooler areas of the liquid. When the entire pool of liquid is heated, the rise in temperature occurs, resulting in boiling point or flash point ignition. In most cases, there is a physical state of transformation from solid to liquid to gas before the combustion can take place. And the last state of matter is gas. A gas is primed for combustion. It is ready mode state that will permit a chemical reaction. A liquid and solid need to be transformed first into a gas for this combustion to occur. Now we're going to talk about thermal balance and imbalance during a fire. Heated air and smoke rise. The hotter the air, the faster, more violent the ascent. Thermal balance is it's reached inside a structure when the smoke from the fire ascends and stops. The smoke establishes equilibrium with the atmosphere. So imagine a fire starting in a room. It goes all the way to the ceiling. As it goes to the ceiling, it's going to go what they call a mushrooming effect, because it can't go up anymore because the fire wants to go up. Then it will go across, and that's that mushrooming effect. This mushroom effect of smoke reaches the ceiling and spreads out vertically. If it can't go any more vertically, then it begins to bank down. Thermal imbalance is caused when water is applied improperly to it. You can use water to extinguish it, but you got to know what to do. You can't just spray water and it will turn to steam and will burn you. You have to do flashes of water. We'll go more in detail later as you go into the academy and when you talk about fire extinguishment. The theory of fire extinguishment. The best way to extinguish a fire is to remove one of the sides of the fire tetrahedron: the fuel, the heat, the oxygen, or that chemical chain reaction. In order to extinguish the fire, you must know what kind of fire it is. And we'll go over fire extinguishers in another lesson. So this concludes the end of week 5. Thank you.